Bismillahirrahmanirrahim. Assalamualaikum. So today, this is a continuation of the process hazard analysis, which is the last one called hazard and operability study, or HAZOP. Okay, so this is the most common method which normally chemical engineers or most of the engineers do HAZOP studies, the hazard studies in most of chemical plant. This is most common implemented in the industry besides ATA, FTA, and so on, right? So basically, the main HAZOP, I'll be showing you step by step. Okay, so this is just a scenario. I just want you to read through it. Okay, for example, you are driving in the midnight, you hit the brake, and this is a slippery road, your car tire strap was thin, the car skidded, so you are having an accident. Okay, so these are the questions that what can cause the accident to happen, and what's the consequences of the event, what can we do to prevent. So these are all the questions where you can ask to in order to investigate the cause of the accident, or the consequences of the accident. So in order to make it more proper, we can do it in a more systematic ways, right? For example, the uh, the parameter that we're investigating is, number one is the car speed, right? The car speed, and you use the parameter, a guide word, causes, consequences, action, and safeguard. So make it in a more systematic way in a table, right? For example, the parameter you are studying is the car speed. The guide word is whether it is too fast or too slow. Or the causes, for example, you are rushing. Consequences, kidded when emergency brake. And what's the action to prevent that from happen? You slow down. Okay, if you're too slow, then you speed up. So you safeguard. What is a safeguard? Meaning that it's a safe precaution method to use, or ABS brake system, safety belt, or airbag. So the second parameter, tire. The guide word, no tread, less tread. Please bear in mind the guide word is used here is whether it is, for example, the word is fast, too fast, or too slow. It's a very simple guide word. No tread, less tread. Very low, no light, right? This is a very simple guide word. So the possible causes. So this you can do it in a more systematic way. So this is the way how we do the HAZOP, but I'll show you on step by step after this, right? So hazard study is a set of formal hazard identification and elimination procedure designed to identify hazard to people, plant, and the environment. All right. So the primary goal in performing HAZOP study is to identify, not analyze or quantify. Remember, HAZOP is not to analyze or quantify. It's to identify the hazard in the process. Okay, right? So this is the definition of hazard and operability. You can just read through the slides. So this is the objective. Alright, if HAZOP is started too late in the project, it can lose effectiveness because there may be a tendency not to challenge an already existing design, because normally HAZOP has to start early when you're designing the plans, right? So if you do the HAZOP too late, so the possibility of requiring redesign the process might happen. You might need to do again the design due to certain hazard that came, right? So that's why hazard need to be done early in chemical plant. All right, there are four overall aims to which identify should address. HAZOP study should be addressed to identify, as I mentioned earlier, to decide whether action is required or not, and to identify ways a problem can be solved, to identify cases which a decision cannot be made, and to ensure that required action are followed through. So these are the overall hazard methodology. Okay, number one, you collect the applicable documents and drawing. You need this item. All this information is needed before you can do a HAZOP. All related documents or drawing related to the design, you need this to collect everything here. So number two, you break the facility into manageable sections, which are called knots. Knot is a section or equipment. For example, in facilities, in But chemical plant, you have a lot of equipments. So you break down them into a section or knots. We'll go through what is not after this. You prepare list of parameters and operation. For each knot, you create a deviation. Deviation means something which is out of norm. Out of normal happens. So it deviates from the normal. Okay. List and record causes for each deviation. List and record consequences for each cause. List and record safeguard or control that may prevent. And list any future action or recommendation. These are the overall method for HAZOP. Okay. Right. HAZOP terminology number one. Cause. What is the cause? The reason why deviation occur. Comment, you can add any recommendation. Consequences is the result of the deviation. What is the consequences of the deviation in case it occur? Right? So this is the terminology that we'll be using in HAZOP. Next is deviation is a way in which the process condition may depart from the intention, which is way out of the normal behavior of the equipment. That is called deviation. Intention design, description of how the process is expected to behave. And this is the keyword or guide word. A short word to create the imagination of deviation or intention. For example, no, more, less, as well as part or other than that. For example, less flow, high, more temperature, low temperature. These are all the guide words you may be using. Okay. Parameter, for example, pressure, temperature, composition, study line note, specific location in the process, which the deviation took place, the process intention evaluation, example, separator, heat exchanger, scrubber, pump. These are all knots. These are all study line. You can do HAZOP according to each knot, right? And you can add recommendation in HAZOP study. Okay. So the main thing, you can refer to the basic keywords of the guide words here. For example, no, meaning that none of the design intend to achieve. For example, no flow, more or higher. For example, it relates to increase. For example, higher temperature, less, decrease, low pressure, as well of in an additional activity occur, part of, some design, reverse, other than. So there's a lot of additional guide words you can use here in order for you to construct a HAZOP analysis. These are the common process HAZOP worksheet. Normally, it consists the project name, okay, the date, how many pages, what is the process, for example, production of what, and then you each the overall process, and then you cluster it by section. For example, this is one section, purifying section. Okay, item number one, study note, what is the process parameter, guide words, possible causes, possible consequences, and action required. So each of these need to have an HAZOP analysis, right? Example of process flow, process parameter, flow, pressure, temperature, mixing, stirring. These are all a parameter. If you can see here, process parameter. So for example, flow, pressure, temperature. These are all the parameter. Okay. And then example of another parameter as well. Okay, guide words. When you combine guide words and parameter, right? So the parameter is flow. So if you want to include guide word, for example, no flow, more temperature. So this is a simple guide words plus parameter for you to include in the HAZOP, right? So causes of deviation, there are three types. You can add a lot of the causes from the deviation, but mainly you have to refer from this main cause, which is human error, equipment failure, or external event. Whenever you want to write down the causes of deviation, please refer to these three, which is human, equipment, and external event. Right? So this is the flow diagram. You can just read through it. Right? Okay, we go to example. This is an example to the reactor system. It's exothermic. A cooling system is provided to remove the excess of energy. So you include a cooling system inside here because it's an exothermic. In the event of cooling function is lost, the temperature of reactor will increase. This will lead to an increase in reaction rate. The result could be a runaway reaction. This is the consequences. With pressure exceeding, pressure is a parameter, exceeding meaning that is a guide word. All right. So perform a hazard study of this particular reactor system. Okay, how example? The guide word here is no, deviation, no cooling. It deviates from the normal. The normal meaning that you need to cool it, but it deviates, no cooling. So what is the cause? The consequences, temperature increase. What is the action? And then, for example, next is reverse. Reverse cooling flow. What is the cause? Failure of water. So what is the consequences? So we go through to the overall, for example, no cooling. What's the cause? Cooling water valve malfunction. Consequences, temperature increase in reactor. So what's the action? Install high pressure, high temperature alarm. So these are all that you can insert or include in the HAZOP sheet so that you can have the action is available for you for your reference to see where if things happen or if the accident happen, you can see what are the action that need to be done, right? Case study next is the shell and tube heat exchanger. Using relevant guide work, perform hazard study on shell and tube exchanger. You have a process fluid coming in, you have cooling water. Okay, the guide word less, more of, contamination, deviation, less flow, cooling water. What's the cause? For example, part blockage. Consequences, more cooling flow, failure of cooling valve, temperature of the fluid decrease. So these are all example of the heat exchanger HAZOP analysis. You can just read through it, right? So HAZOP, for example, no cooling water flow, failure of inlet cooling water to valve. So the action to install temperature. So these are all the guide words, deviation, causes, consequences, action. Remember to cluster the table into this cluster, right? Guide word, deviation, causes, consequences, and action. So this makes you easier to perform the hazard study, right? So this is the overall hazard of for a polyethylene plant. So the overall plant, so there are a lot of equipment here. So you can separate them by knots. Okay. For example, you can just read through it. Okay. Knot number one is the reactor. Okay. The parameter that you are doing the HAZOP is the temperature. Okay, the deviation guide word is higher. So what is the possible causes of higher temperature? For example, coolant pump reactor fail, coolant temperature high. So possible consequences, run away. So action required, provide temperature controller. So this is for the same, next for the same study note, for the same parameter, you use a different guide words. For example, lower. So what's the possible causes? Coolant temperature low, poor, no reaction, quality product. So what's the action required? Next, you can also use a different process parameter with the same study node reactor. For example, flow. Flow, it could be many flow, polyethylene, ethylene, or initiator. So the guide words is no flow, less flow, more flow, less flow. So this is simple. You just follow no or less, more or less, right? For example, for reactor, the study node is reactor. The process parameter is flow polyethylene. Deviation is no flow. What is the cause of the no flow for polyethylene? For example, melt pump 1 fails. Consequences, level build up in reactor. So what are the action? Provide reactor. So each one of this you can write down the hazard study, right? So this is example for study note on the reactor. You can also study on different note. For example, the heat exchanger, for example, that we have done previously. So different study note will give different deviation word, will give different possible causes and lead to different consequences and also action required. So these are the way how you perform a HAZOP study on each of the knot for a chemical plant. Right? You can just read through it, understand, and you can just buzz me with a question pertaining to the slide, right? So you can just, this is a limitation of the HAZOP, you can just read through it, right? So that's it. I'll give you example in the YouTube as well, so you can just read through it and try to read the slide and some additional note. Additional, I'll be giving also some additional notes on this. All right. Thank you very much.